Rada, can you just pass me one of those books there? Thanks. Thanks. Guys, sign on. Just use the regular link. Usually I'll change it, but I'm in too much of a rush today. So. Done? Yep. Thanks. Jeez. Sorry, guys. I'm having internet problems. It's just over and over and over. Okay. I for your workbook. Okay, so let's look at finally page 112. Thanks. Okay, the first one is sodium. I'll write it out. Sodium plus chlorine. Produces salt, table salt. NaCl is table salt. Okay, now balancing this one is pretty easy. Chlorine's got the 2, so you got to balance the chlorine. You're balanced. Now, as far as categorizing, that's what we're supposed to be focusing on. You've got element plus element produces a compound. So it's synthesis. Okay. B. Zinc plus nickel chloride. Okay. Produces nickel plus zinc chloride. Okay, so look what's happening here. We've got a replacement going on. The zinc is replacing the nickel. They're trading places. So there's one element, in this case, it's a metal being replaced. So it is single replacement. I'll balance it in a second here. Yeah, it looks like it's already balanced. So, right, balanced. Single replacement because the zinc is replacing the nickel. They're trading places. One of those days. Okay. Next one, calcium hydroxide plus hydrochloric acid. So this is an acid-base reaction. How do I know? Well, it involves an acid and a base. So it's an acid-base or neutralization reaction. How do I know it's an acid? Well, this formula starts with an H, so it's an acid. This formula ends with an OH, so it's a base. So with an acid-base reaction, you've got to remember that you're always going to get water. I write it as HOH. It's easier to balance. It's just a reminder that water has one hydrogen and one hydroxide. And then what's left over in this case is the calcium and the chloride. You give CaCl2. Okay, you can actually predict the products. Now, it's not balanced, but we can easily balance a neutralization reaction. How do we do it? We try to balance the hydrogen and the hydroxide. We should have the same number of hydrogen on both sides. So there's one hydrogen here and one here. So far it's balanced. We also have to balance the hydroxide. There's one here, there's two here. So look what I'm doing. I'm trying to balance the hydrogen and hydroxide first. So put a 2 in front to give me 2 hydroxide. To match the 2 hydroxide here, indicated by the subscript. But that changes the number of hydrogen. I now have 2 hydrogen. So I have to put a 2 in front here. Now it's balanced. So the way to balance a neutralization reaction is first recognize it. And then secondly, try to balance a hydrogen and hydroxide. Do that first and the rest should balance pretty easily. Okay, and again, you can call it either, no both terms. So, an acid base or a neutralization reaction. I didn't write it in reaction, but it's there. Really? Silver nitrate. Jenna didn't hear that. Breaks apart into I'm reading off my phone here. Silver. It's not silver, is it? Can't even read. It is silver. Sorry. I can't read this small print. I can, but it's hard. Here, I'm going to borrow your book. I'll just write this to it down. Okay. Next one, silver nitrate produces NaNO2 plus oxygen. So it's a split. It's a breaking up into two smaller parts. This is smaller. NaNO2's got less atoms than. Why did I do that? Sorry. Start again here. D, silver nitrate plus NaCl. NaCl produces silver chloride plus NaNO3. Okay, so look what's happened here. We have 2 compounds, compound plus compound. That's usually an indication you've got double replacement. Let's just be doubly sure. Get it? Doubly sure? Yeah. Okay. I tried. Okay, wasn't that funny? Okay. The silver, the Ag trades places with the sodium. See that? The silver is now replaced with the sodium next to the NO3. Similarly, the sodium has switched placed with the silver. So the silver is now next to the chloride. So yes, it's double replacement. 2 elements have been replaced. So it's double replacement. Double replacement. Two metals have been replaced. Wow, I'm making mistakes today. Double replacement. E. NaNO3 produces NaNO2. This is the one that breaks apart into smaller pieces. Okay, you got a compound. Usually it's an element plus element, could be a smaller compound. Okay, decomposing, decomposition. It's breaking apart. Next. Is it balanced, by the way? Let's see. No, it isn't, right? Can we balance it? Let me do it quickly. 4 oxygen here. What I need, I can do this. It's kind of cheating, but there's a half in front, right? Does that balance it mathematically? Just take a look what I did. Put a half. Mathematically, it's correct, right? Well, you can't have half a molecule. That's the problem. So multiply, put it in brackets. Multiply each of the coefficients by 2. So what do you end up getting? You end up getting, yeah, 2 NaNO3 produces 2 NaNO2. 2 times a half is just 1. Okay, now it should be balanced. And next, CH3OH plus O2. Produces, whenever you have this combination, this is what we call an organic molecule. It's made up of carbon, hydrogen, and there's an oxygen tacked in them. It's actually some sort of alcohol. So it's methanol, actually. So when you combine any sort of hydrocarbon, or even a hydrocarbon with an oxygen tacked onto it, you're always going to end up with carbon dioxide and water. Always. Those are your predictable products. It's called a combustion reaction. You have something, any sort of molecule reacting with oxygen, called combustion. Okay, balancing it. I do a table. Okay, so carbon, hydrogen, and oxygen. Okay, carbon's balanced so far. Hydrogen, 4 here. There's 3 here. Plus 1 is 4. Hydrogen here is 2. Oxygen on the left is 1 there, 2 there, 3. On the right, 2 there, 1 there, 3. So balance of hydrogen. Put a 2 in front. That makes it 4. And now there's 2 plus 2 oxygen for a total of 4. Can I make it so there's 4 on the left? Yeah. Is that mathematically correct? Just check it. I'm not interested in whether it's correct chemically yet. We'll get to that. I put a 3/2 there. 3/2. This times 2 is just 3. 3 plus this, 1 oxygen is 4. So yes, mathematically it's correct. What's wrong with it? What's wrong with the 3/2? It's a fraction, so what do I have to do? Very good. Multiply by 2. Multiply by 2. I can cheat. Put that down there. I get 2 CH3OH plus 2 times 3/2 is just 3. Produces 2 CO2 plus 4. Okay? And yes, it's a combustion. G. Hydrochloric acid plus oxygen produces water plus chlorine. So, what's being kicked out? The oxygen is kicking out the chlorine. So that chlorine is all by itself. The oxygen is replacing the chlorine. So this is called single replacement. One of the elements, in this case, it's a nonmetal, being replaced by another nonmetal. Single replacement. Okay, there's two types of single replacement. Either the metal is being kicked out or the nonmetal is being removed. In this case, it's a nonmetal. Okay. Is it balanced? Well, no, not yet, but it will be. 2 chlorine. Let's try this out. 2 hydrogen, 1 oxygen. So far, everything's balanced except the oxygen. I've got 2 chlorine, 2 times 1, 2 chlorine. 2 times 1, 2 hydrogen, 2 hydrogen. The oxygen, there's 1 here on the right, 2 here on the left. Put a half in front. What do I need to do? Multiply everything by 2. So I get 4. 2 times a half is just 1. Okay. H. Combustion. Right away, I can see what it is. This is a hydrocarbon. Hydrocarbon. Got only carbon and hydrogen. What are the products? Always carbon dioxide plus water. Always the same. Is it balanced? No. Okay. Didn't want to spend too much time on balancing, but 5. Just doing this quickly. 6. So far, carbon and hydrogen is balanced. 10. 16, 8. Check my work. Is that right? I'm going to recheck it here. 10, 16, yeah. This, because it contains a hydrocarbon and an oxygen, what do we call that? Yeah, combustion. I, sulfur dioxide plus water comes together to produce hydrogen sulfite. Okay, if it's an acid, we'd name it sulfurous acid. Now, what do we have? We have a compound, a smaller compound, plus another smaller compound, producing a larger compound. It's synthesis. Two things coming together to produce one. It's already balanced. Yeah? J, aluminum chloride, plus sodium carbonate produces aluminum carbonate. Plus sodium chloride. Okay, so what type of reaction is it? Compound plus compound. That is your basic pattern. That should remind you what it is. Compound plus compound. Double replacement. That's usually enough. You want to check it? Let's check it. What's happening? The aluminum is replacing the sodium. They're replacing each other. The aluminum is now next, instead of next to the chlorine, is now next to the carbonate. Next to the carbonate instead of the chloride. Okay, so yes, two things are being replaced, so it's double replacement. Okay, K. What kind of reaction is this? Just looking at the first two compounds. Good, neutralization. What's it always producing? It always produces water. I'm going to write it as HOH. What's left over? The metal and the non-metal, or polyatomic in this case. So you get K2SO4. Okay, so yes, it's neutralization or acid-base reaction. How do you balance it? The trick is, again, balancing the hydrogen and hydroxide. So I got 2 hydrogen here. You got to put a 2 in front to give me 2 hydrogen. That changes the number of hydroxide. There's now 2 hydroxide on the right. How do I make it so there's 2 on the left? Just put a 2 there. It's balanced. Ignore that. That's a summary of my day so far. So just ignore it. Not you guys. It's just trying to get things done. Next, HGO, mercury 2 oxide, produces mercury plus oxygen. Okay, it's one compound breaking apart. What do we call that? Good, decomposition. Okay, balance, not yet. Put a 2 there, put a 2 there, done. And I'm running out of time. We got 5 minutes to. I'm not in a hurry to finish the rest. I'd rather give myself 5 minutes just to come around and help a little bit. Before I go around and help, continue working on page 113. That's your homework. Finish 113. Write it all out. I'll go over that definitely next day. Now, just before we begin, or before I can go around and help some people here, let's take a look at, go back to here. Let's see if we can figure out whether any of these are endo or exothermic. I'm going to put that in appropriately. Sure, pink. Pink's got a kind of energy feel to it. Any sort of acid-base reaction. Actually, let's start with the first one. That's a little confusing. Let's start with the first one. So, first one is synthesis. Synthesis always are exothermic. Okay? Whenever you form a bond, you release energy. You're bringing sodium and chlorine together to form sodium chloride. You're forming a bond. Energy is released. It's exothermic. Okay, we can't do all of these, but some of them, like double or single replacement, there's no definitive answer. Some of them are exo, some of them are exo. Let's scoot down to C. C is neutralization. Notice you're forming water. You're splitting the hydrogen up from its original bond, the hydroxide up from its original bond, and you're forming water. Water is a very strong bond. That's why there's so much of it. That releases, whenever you form a strong bond, that releases lots of energy. So these are exothermic. Any neutralization are exothermic. Okay. Again, double replacement could be either. Decomposition, that's always going to be endothermic. You have to split it. You have to add energy to it. So this is going to be endothermic. You're putting energy here. You have to add energy to split it apart. I know, I'm running short of time. I'm not even going to get a chance. This is crap. Okay. Next. This is obviously combustion. You know from experience what's released in combustion that you visually see in a lot of cases. Heat, flame. So it's very good. All combustion are exo. Double replace, single replacement, we don't know. Combustion, again, exo.
Please excuse the interruption. When the classes
synthesis.
Go on break, could Pia and Zoe DeGlocco come to the office for a pickup? On break, Pia and Zoe DeGlocco, please come by the
Exo.
office. Thank you.
Okay, you're forming a bond. Whenever you form a bond, you're going to release lots of energy, exothermic. J, double replacement, we don't know. Neutralization, again, you're forming water, which is a strong bond. That usually overtakes anything else. Exo. Forming of a strong bond means release of lots of energy. Decomposition, you have to add energy to decompose. Endo. Okay, so finish off page 113. Do the same thing. What I just did, figure out if it's exo or endo, if you can. Add that to it. Shoot. Thank you. Yeah, let's do it. Problem is, tomorrow you need a tutorial. I gotta leave her. I can come in myself. Can you make it after school? Let's do it. And then you write it Wednesday. Yeah, it should be a stapler. I don't know where. Yeah. See if you got it there. See you guys. Have a good day. Thank you. Take care. You're welcome.